Hi there, I'm Nick, and this is Reinforced, a show where we're going to help you improve your design for 3D printing skills and have some fun along the way. Today we're going to be talking about strength. So specifically, how we can improve the Z-axis strength of our 3D printed parts. And if you stick with us for a couple minutes, I can guarantee you that I can help you make some of your parts instantly stronger with just a little bit of redesign. So let's dive in. If you've been around 3D printing at all, you've probably heard that the Z-axis is weaker than the XY plane or in each layer of a 3D printed part. This can be a problem because you may not expect that part to have those different properties in different directions. You may expect to have a uniformly strong part. So why should you care about the strength in the Z-axis? Well, you want it to avoid broken parts. Imagine you were using a part like this and didn't realize that it didn't have enough strength and you assumed it was going to work, and all of a sudden when you put it into practice, it splits down the middle, cracks, and ruins your day. No one wants that, and so that's why we need to think about how to reinforce those parts against those weaker axes. Having stronger parts will mean that you can use 3D printed parts in more applications, give you more capabilities in those parts, and just generally make 3D printing a more useful tool in your everyday work. So the first thing we need to talk about is this word, anisotropy, or the characteristic of having different material properties in different directions or axes. So a classic example of anisotropy is wood. Have you ever cut down a tree or split a log? So if you have, you probably noticed that it was easier to split that log along the grain than against it. And that's anisotropy at work. The wood is very much stronger in one direction than another. So wood's just one example of anisotropy in nature, but you've probably run into others around you. And guess what? 3D printing also is anisotropic. I should be a little bit more specific there because there are some 3D printing processes that are more or less anisotropic than others. So when we're talking about 3D printing today, we're going to be talking about filament extrusion 3D printing like what you'll see with your Markforged machine, amongst others. And so if you're building a part layer by layer and extruding plastic or composite fiber into that part, you're going to see anisotropy between the layers. And this is where the classic example of 3D printed parts are weak in the Z-axis comes